Good morning, everyone. I hope you can hear me well. I just wanted to give you a quick note from my side. I have some technical issues for my camera on my computer today, so I will be joining also from this mobile device so we can see each other. I hope you can hear me well. Can you confirm?
I can hear you fine. Can you hear me?
Perfect. So that's
Great.
my workaround solution. We will just wait 1-2 more minutes to give everyone a chance to join, and then we will start the webinar.
Oh, dziękuję pięknie.
So, good morning, everyone, and welcome to today's webinar, BeeGFS in Practice, Parallel File Systems for HPC, AI, and Data-Intensive Workloads. My name is Božidara Pellegrini, and I represent the National Competence Center for High Performance Computing in Slovakia, part of the EuroCC initiative. And thank you all for joining us today. As HPC and AI environments continue to evolve, storage architecture is no longer a background topic. It directly determines scalability, efficiency, and performance. Parallel file systems therefore deserve focused attention, not only as infrastructure components, but as a strategic layer of modern computing environments. BeeGFS is one of the few European-developed parallel file systems, which makes today's discussion particularly relevant in the current HPC landscape. This session gives us the opportunity to explore its architecture and practical deployment, looking at how the system is designed and how it operates in real HPC and AI environments. I am pleased to welcome Dominic McHenry, Business Development Director from Northern Europe at ThinkParQ, the company behind BeeGFS, and Ingo Martini, Pre-Sales Director, BeeGFS at ThinkParQ. And they bring both strategic insights and deep technical expertise to today's session. So before we begin, just a brief organizational note. The webinar will last approximately 90 minutes, including the time for the questions in the end. So please feel free to use the chat at any time during the presentation, and we will address all of your questions during the Q&A section. And with that, I will now hand over to Ingo.
Yeah, hello. Welcome to this webinar. Thanks for the time that you share with us. I'd like to introduce my colleague, Dominic McHenry. He will start with this short presentation with a short intro into what ThinkParQ is doing and what BeeGFS is in general, and then I will take over the technical part to explain a little bit more in detail. If you have any question, please send us a chat message. I want to see this at the end of the presentation that we have a Q&A session there. If there is something completely unclear or not well explained, let me know, and I can also try to explain it in a different way and get your questions answered. And so I want to hand over to Dominic.
Good morning, dobre rano. Mamy prezentację po polsku? Yeah, that's about the extent of my Slovak. But I'd just like first of all to say thank you very much to Lucia and to Božidara for inviting us to do what is going to be the first of a series of webinars for the EuroCC. And I think it's just great to be doing it in Slovakia. I actually spent 4 months in Bratislava working for Dell in 2005, had an absolutely great time, still travel to Slovakia fairly regularly, hope to meet the EuroCC guys soon. And, I'm looking forward to talking about our product and perhaps developing our business in the region. So yeah, the first slide. Yeah, who are we? So ThinkParQ. Technology empowering human development. It sounds quite big, but you're going to see in the course of the webinar, a number of important areas where BeeGFS and also our sister product Beyond are actually making a real difference to people's companies, people's lives. Are working in areas like research, medicine, finance, that sort of thing, to actually make computing more effective. What do we do as a company? Well, we develop the software, and what I mentioned that BeeGFS is one of the few European parallel file systems, and exactly what a parallel file system is, I'll explain in a moment. In actual fact, it's the only 100% European parallel file system. And, it's received, a number of, well, it's basically got a subscription for the HPC Wire Reader's Choice Award, which is one of the few awards in the industry that's actually given on the basis of a vote in the HPC community, which I think also, underlines the extent to which we have a real following and people who are really enthusiastic about this product. Yeah. What does it do? Well, BeeGFS, we've got here. It's the leading parallel file system. So what it allows you to do is basically to write data to multiple storage targets, multiple servers at the same time. And you can think of it as almost a little bit like a library. So if you yeah, okay, I thought this slide was coming. I expected it to be the other way around. Yeah, so the famous analogy that we often make with the library. So if you come to a library and you have one librarian, then normally there's a line of people waiting to get and to return books. But if you use the equivalent of a parallel file system, you suddenly have lots of librarians who can return and give out books at the same time. So it makes reading and writing data much faster. And you can see, the main points there at the bottom: speed, because you're working in parallel. So applications like, for example, AI, training large language models, that sort of thing, we can look at, function significantly faster. These parallel file systems are normally highly scalable. So as your business grows, as your organization grows, as your needs grow, you can, okay, you're running ahead of me here, but I'll keep going here. Yeah. These systems are also highly scalable, and we'll look, particularly at BeeGFS in terms of scalability. And I know that a lot of you are perhaps coming from, SMBs, from startups. So sometimes, it's difficult to assess, what your storage needs are going to be in 3 years and 5 years. If you look at a system like BeeGFS, then it's quite easy to scale up. Reliability, Ingo is going to talk about, a lot of the kind of failover, high availability features that are available as part of BeeGFS to ensure that your data is always available, minimize downtime, and finally efficiency. And there's a lot you can do in areas such as tiering data, putting data into different groups to ensure that you're only spending money and only spending resources on really fast, hot data where you need those, and you're storing perhaps data which you need less often, more efficiently, and more cheaply. Yeah, why BeeGFS? There are other parallel file systems on the market, but I think some of the main features that we bring to the table and we're going to look at in terms of performance. There are certain applications that rely on lots of small files, certain applications, thinking of things like media and entertainment, video files, that sort of thing, that rely on really large files. I think we have a solid performance across different types of applications and file sizes. Scalability, I spoke about that, and that's something I think that's very relevant, especially for a lot of SMBs and for a lot of startups. Ease of use. Normally, the way we work is that we have partners who sell our product. We have a partner for Slovakia, we'll go into that, and they look after first and second level support, and we normally give their guys a 3-day training course, and that's pretty much sufficient to deal with all the first and second level functions and typical tasks that they have to do. And as it moves more into the area of development and customizing and developing our code, then that's something that we do in-house. I spoke a little bit about the system being robust and high availability. Ingo's going to go into that in a bit more detail. And last but not least, what we have in the latest iteration of BeeGFS is support for S3, which is the storage system that's used, for example, for cloud storage with people like AWS. And that's something that we can support. So we can now use BeeGFS in some of the perhaps typical hybrid environments that we come across in the HPC space nowadays. Yeah, we called out the fact that BeeGFS is the only 100% European parallel file system. And therefore, I think it's great to be part of the EuroCC and to be talking about things like digital sovereignty. We do have a lot of customers. We're also seeing increasingly a lot of public tenders, certainly in Germany where I live, that are now specifying European digital sovereignty as part of the criteria that they will use for choosing suppliers. Yeah, what it means, the ability to control your own data, digital infrastructure without dependence on non-European providers. So if a parallel file system is part of your software stack, then BeeGFS, I think, is the obvious choice. Just a little bit of background there on who we are. We actually come from a research background from the Fraunhofer, a big research organization in Germany, in a place called Kaiserslautern, and we were spun out in the 2010s and have been growing as an independent country, an independent company, sorry, since then. And yeah, just the main points of digital sovereignty, GDPR compliance, European control is something that we can offer. Strategic independence, which I think is the whole point of the EuroCC and the Euro JU, and I think it's exciting for us to be part of that. And then obviously, we are developing and working in Europe. We are subject to European regulations and standards, and can contribute to ensuring that your software stack also has those features.
Okay, thank you, Dominic. And from here, I like to take over. And as I expect not everybody in the audience has an idea about how these parallel file systems working and how they are different from a NFS server or a standard local storage. Maybe we can have a short introduction in parallel file systems in general, but also how BeeGFS is working. In a parallel file system, you mostly have an distributed approach. That means you have several storage servers, several metadata servers, and you split the data from the file system metadata. That means you have a dedicated system available that is only handling the metadata of the storage. So that means file position, file names, permissions for this file, creation date, last access date, all these things, access control lists, all these things that are file system metadata. And why do we do this on a dedicated service and not together with the data? That's all about performance. Parallel file systems are built to handle billions of files at the same time. So that means if you have a large environment, if you have a lot of files, small or big files, doesn't matter, and you want to find something, this is a typical metadata operation, and therefore you need something that is very fast to give you these informations. If you have I would say a standard server with a 4 or 6 terabyte NVMe, and you have a local file system there, and you search for something, this takes already a few seconds if you do a find or something like this on this metadata to get information about a specific file, or give me all the files that belonging to a specific user or something like this. If you do this in a petabyte or multi-petabyte environment, and you say, show me all the files that belong to this specific user, this can take ages. And that's why we have this approach to have a scalable metadata service where we have this information on a dedicated service. It can be a dedicated server, a physical server, but also a server where we have specific services running. I will explain this a little bit more in detail later. And we have dedicated servers that only storing the blocks of the files. So we're calling them chunks. And for example, a single client wants to write a file into the BeeGFS file system. First operation that the client will do is connecting with the metadata server and send this information to the metadata server and say, hey, Mr. Metadata Server, I need to write a file. This file has a certain size, and please tell me where to store this information. And then the metadata server stores this and gives the client back an information, say, you see 3 storage servers, please put a chunk of these files on each of these storage servers, and the file is written. The same for the second client. They're always communicating to the metadata servers. They have the information about where is space, where is free space for this, how can I allocate this storage, and the metadata server will give them the information back and say, okay, please use storage server 2 and 3 for your file, and then the client will write it directly. In this case, the client and the storage servers have dedicated connections. That means they don't go through a bottleneck. They don't go to a single server as a gateway. They have a communication path to the metadata server, and they have to each of the storage servers their own communication path. This also helps if a client wants to read a file, so they can have direct access to all of the storage servers and read the files or the chunks directly from there. And also if they want to delete the files, the client can also send this information on the metadata server that the file should be deleted, and the metadata server will inform the storage servers about deleting these chunks. So that means for all these file system operations, we're using the metadata service, and only for storing chunks of the files, then we're using the storage servers. The same for the second file. And this is how a parallel file system is distributing specific work or jobs to specific services. File system information is one thing that's stored in the metadata service, and storing the files itself or storing chunks of the files is a job for the storage services. That's why we have these dedicated services, and both of these services can be scaled out. So you can have multiple metadata services, but also multiple storage services to scale the system in 2 directions. And if we talk about scale, if we talk about performance, if you talk about the parallel file system, you usually talk about two different things if it comes to performance. One is the file system performance itself, and file system performance is something that we calling, if we say we want to have a listing of a large directory, we want to have a find on this, we want to create new files, we want to delete, we want to remove, we want to rename files. All these are pure file system operations and have nothing to do with the chunks of the file, with the data of the file itself. It's only information about the file itself. Renaming a file doesn't change anything on the data, it only changes the metadata for this file. And this is what we're calling the file system or metadata performance. And the other topic is the bandwidth that the storage can provide, mostly measured in gigabyte per seconds. So how much throughput can I get from the system if I write files? How many gigabyte per second can a storage provide? And depend on your application, depend on your use case, your raw data that you try to operate. These are two different things. So if you think about machine learning or AI workloads, you mostly will see a lot of small files, but therefore maybe million or billions of files that you create there. If you are working for a better forecast or for an oil and gas company, they have mostly large, very, very large files up to multiple terabytes in size, where they have their data to analyze, where multiple nodes reading the same file at the same time. So to do some analysis on the data that is there. So these are complete different use cases, and depend on what you're doing with the system, you can tune or scale the system in different ways. If you have to handle more files, you need more metadata services. If you have to handle larger files, you need more speed from the storage itself, you can expand this on the storage service side. And here's the BeeGFS architecture. We usually need four services for running a BeeGFS file system. And this is the ease of use that Dominic mentioned before. It's extremely easy to set up a BeeGFS file system. If you compare this with other stuff, I have done workshops where I explained students about the difference between an NFS and a parallel file system. And afterwards, we have done a 45-minute hands-on session where they are able to set up a basic parallel file system within 45 minutes. So that means it's quite easy to do this. And it's only these four services that we need. The management service is our brain for the file system. So it has all the information, who is part of this file system, how many servers do we have for metadata, how many services do we have for storage, where are the clients connected, what kind of IP connections or InfiniBand or OmniPass or whatever connections we have. All this is stored in the management. The metadata service is there to store file system metadata, so file names, access times, permissions, directory structures, all these kind of thing. And it's not involved in the data stream, so that's important. The client have a direct connection to the storage, so if they want to read something, they're only talking to the storage services, no longer to the metadata services. The storage service is there to store the chunks. BeeGFS is cutting files into chunks and store different chunks on different storage targets, so we can leverage the performance of a single storage target and put multiple of them together so that we can multiply the performance that we will get out of these. If you think about a single RAID system, a single target and a server can provide a certain performance. If you could split your file and write a part of these files to 4 different servers, you will have the 4 times the performance that you want to have if you write only to a single server. That's the idea about these scaling and these target and splitting files into chunks and write them to different storage services. And last but not least, what we need for a file system is the client, the one who is really using the file system, who is writing files to the file system itself. And this is installed on the client, on the compute nodes, so that they see a POSIX-conform mount point where they can read and write their files to. Important to know, the management, meta, and storage service for BeeGFS running in user space. This is particularly interesting for administrators and for security. If you have to patch your servers for security patches or whatever, then it's mostly uncritical because these services running in user space and not depending on a specific kernel things. The only thing where we have a client kernel module is on the client itself. This is for performance reasons and to implement the RDMA functionalities. There we have the kernel module. That means if you want to update your clients, the client will, after the restart of the BeeGFS client service, rebuild the module and then mount these as a kernel module, and then the client can mount the file system itself. So this is what we need for a file system. It's only these 4 services. They are easy to install, RPM packages, and then you give a setup command and that's it. The monitoring service is already an add-on. Our monitoring is completely based on open source. So we're using Telegraph, Grafana, and InfluxDB to build a monitoring service here. It's completely described on our website how to do this, but you can also use your own monitoring if you have already your monitoring in place with Nagios or with other stuff. You can easily use the translators from the InfluxDB and connect them to your existing monitoring. So that's quite open to see. If we look into an HPC environment, usually you can see such a kind of architecture. You see if we start from the other side, you see the application layer. This application layer is reading data to a POSIX conform file system. These applications usually are running on client compute clusters. So this can be a CPU cluster, GPU cluster, whatever you have. We are also supporting GDS, so GPU direct storage. If you have some software developed in this case, there's also connected via mostly an RDMA network. Most of our customers, I would say, using InfiniBand or Ethernet. We have a few customers also using OmniPass. Also, this is supported. So depend on your infrastructure, depend on what you find locally, or even what you find in a cloud support. You can use this connectivity to speed up this. Important, the less latency you have on your network, the better is the performance overall, metadata, and also the storage performance. So that's why we're talking not only about high speed, we're also talking about low latency for this kind of storage networks here. And what you can see, the clients have a direct connection to all of the nodes, to the metadata nodes, storage nodes. So they have a direct line, so they can connect directly to these in InfiniBand connectivity. They will create their own queue pairs between the client and the meta and storage nodes and transferring the data packages there. So that's why we're talking here about extreme low latency. Usually we see round trip times from a client to a meta or storage node back to the client within 2-digit microseconds. What we're talking here about the exchange. So it's very high speed on this. And what we here can also see that the management and the monitoring node are sitting a little bit outside, only in the management network. They only have informational characters, so they only talk about what is available. Are the nodes there? Are the services running? Are they available? Do I need to do some kind of failovers in case a storage or metadata node needs maintenance? This is only some kind of operational stuff outside, has nothing to do with the data path. The data path in our example here is the yellow one. So there is where really data flows away. And this is usually the high-speed network that we use here. For monitoring management, we don't need a high speed here. What you also see on the storage layer and below on the storage layer, usually you don't have only one single file system in an environment. Usually you have at least 2, maybe sometimes 3 different storage solutions in place. One storage solution is optimized for user access, home directories, maybe for some office stuff. Others are optimized for long-term preservation with versioning and ransomware protection and so on. And therefore, most of our customers are utilizing multiple storage systems. And this is also something that you need to consider if you talk about an HPC high-performance scratch file system, that BeeGFS is built for performance. BeeGFS is not built for long-term preservation, for additional safety of your data, or for snapshots or versioning or something like this. This is not included. BeeGFS is really built for a high performance stuff that is connected to your compute nodes, and therefore it is easy to use and give you a lot of performance from your hardware that you have. And it's important to understand there are different storage systems for different use cases optimized, and that's why it doesn't fit always. There is always a use case where we need to say, okay, this could be something for another storage system that has nothing to do with a scratch with a high performance file system here. So only to make this point to say we don't fit in every workflow. It should be a high performance HPC AI machine learning workflow. As mentioned, our monitoring tool is built on Grafana. You can see here a template that we bring with our software itself. So we have multiple templates installed on Grafana, but you can also build your own dashboards. If you want to see a specific value utilization of network passes, temperatures, whatever, then you can build your own panel. So it's complete open. You will have complete administrator rights to change everything here. That's only templates that we bringing with our software that shows you the, I would say, what we believe is important on the first step, but you can also create your own dashboards and do some changes here, change the values, change the parameter that you want to see, want to monitor. And you can also use Grafana to get notification if you reach specific thresholds, if you reach specific utilizations, file system utilization, network bandwidth utilizations. If it comes to congestions, then you can use this also to send notifications and get informed about this. Important, if we talk about data center storage, is also high availability and what options BeeGFS can build here. As mentioned before, there are different use cases for different storage solutions. So sometimes it makes sense to have a very secure safety environment where you can say, I can store my data here for years, for 10 years and longer. Sometimes you say, this is scratch data only. I can reproduce this data, or I have this data on a central repository safe already. What I'm looking is only for performance, because most of the time you don't get both. You don't get the best performance and the highest security, because all of these things coming with some kind of costs. Is it erasure coding? Is it versioning? All this will always add a little bit of a latency to your data if you want to do this. And that's why this is important to understand what is your need and what you're looking for. But we have the possibility with BeeGFS, with different deployment options, to create a complete high availability HA environment. So there is no single point of failure any longer. We can really set up systems in a way where they can, in this example, use shared storage for storing data and metadata. In this case, there is nothing, no single point of failure in this old configuration. If we think about here, we see 6 storage nodes. They are connected to 3 shared storage systems. This can be a shared storage system that is attached over a SAS cable to both of these servers, having 2 storage controllers like a NetApp E-Series or Seagate Core Vault or Dell ME5084 or whatever you have in your environment. The benefit here is the storage itself has already dual controllers. They are connected to two different storage nodes. And in case one of these storage nodes will fail, the other storage node can take over the storage services that are communicated to the clients, and the client will have full access to the data. They don't recognize anything on this failover in the background. So that's important. This is something we can build. We're calling this a shared storage environment. And as mentioned here, storage node 1 has half of the storage mounted and distribute to the clients. Storage node 2 has the other one of the storage X. And in case storage node 2 will fail, you will see that storage node 1 will take over the services from storage node 2 and the service A and B is now running on storage node 1. We're using here virtual IP addresses to address the storages. After the client has connected with the storage node over a TCP/IP connection, they will switch to an InfiniBand or RDMA connection and then sending their data over an RDMA. You can also build this in an Ethernet-only environment. So if you at the beginning say, we want to start with an Ethernet-only solution, that's no problem. You can also run in the mixed environment. If you have a few clients connected to an RDMA network and a few clients connected via Ethernet, this is also possible to mix and match this, depend on you. Especially if you talk about scalability, if you grow over time, if you're starting, you may have not the requirement to have an InfiniBand switch and an RDMA network. You want to start with I would say, smaller Ethernet approach, but later maybe you want to upgrade the system, want to have more performance, more capacity, and also going for a faster network. That's possible without any data replacement. You can do this with data in place. You only change the network topology and maybe a few configuration files, and then you can work on it. So this is really easy. That's also one of the things that important for BeeGFS. BeeGFS is hardware agnostic. That means we are not bound to any hardware vendor. We have some relationship with a lot of hardware vendors. We do some testing. We do some reference architectures with them. Some of these vendors selling our software also, the software solution on top of their hardware stack. But BeeGFS itself is hardware agnostic. It's running on Linux systems, on x64 platform, but also on ARM. So if you have an ARM environment, you also can run this with these nodes. Another topic or another thing that you can do with BeeGFS is mirroring your data. If you don't have the possibility to use shared storage, if you have an environment where you have maybe only a few servers with NVMEs, you can also use a mirroring and synchronous mirroring mechanism here. That means you have two storage servers or services running, and they are connected, have their own storage built in these servers. We can do then a mirroring. So in this case, if the storage node 1 will fail, the system will replicate the data, all the data that comes in to a second storage, and from there the clients can read the data from the second server if one of the servers will fail. It's important, this mirroring is a synchronous mirror. That means you don't have any lost data. If the system comes a complete power outage, everything is safe. The other side is that always comes with a performance penalty, because if a client sends some data to storage node A, they will store the data on their own storage A, but in the same time, this service will send this data over to storage node B and do a replicate of this data. So that means you have both servers in this case replicating crossover their data. They do this for metadata, and you can also do this for user data, so storage services as well. The challenge here is you need twice the capacity and the server for this. So you need twice the hardware for doing this. On the other side, this is really extreme safe. If one side will fail, if one server will fail, you have the data twice on different storage environments. And this gives you a very high availability and high safe environment. The topic is this comes with a performance penalty, because we have to wait until the second server acknowledge their writing to the storage, and then we can send it to the client. So this is something you need to consider if you say sizing, if it comes to performance requirements. This is something we need to be aware of. But it is one way to create a very high available and safe system. It depends a little bit on what you're doing. If you are on a university and you do some software development and you want to run some tests and some smaller jobs, you may see this as an overkill. If you are a finance institute and you want to do real-time trading, this is never an overkill, because if you lose there a few seconds, you may lose a lot of money during this time. So that's different use cases, different requirements, and therefore we have different possibilities to build systems in a high available environment. It's our HA setup with shared storage or the body mirroring. So, sorry, it's a little bit depend on what you try to achieve. And this also shows a little bit the flexibility that BeeGFS can provide. So BeeGFS can, for you, build a solution that fits your needs. You don't have to take something from the shelf and say, yeah, that's how it works, and I have to use it this way. In most of the cases, we have a longer discussion with our partners and customers upfront if they're planning their new storage system for their HPC environment. We talk to them and say, okay, explain what you try to achieve, explain to us what you have on the requirements, not only performance-wise, also which applications are you using, how do you want to stage in, stage out data, do you have a central repository for all this stuff, so that you really invest in a solution that is really tailored for your requirements, and this is what we try to achieve. On the one hand, BeeGFS is ease of use and it's easy to install. On the other hand, it gives you a lot of opportunities to build your system that fits absolutely your needs. And therefore, a call is necessary to get in information or to have a strong partner that has a lot of knowledge about it that can help here with a solution design that fits your performance and requirements, but also fits your budget. And this is very important to understand. As we are hardware agnostic, we're also supporting, I would say, hardware using in a second life. If you think about have some servers that may not fast enough for the work they are bought for, maybe they are coming from an database environment, having some NVMEs built in, but they're also a replacement. Now they are left over, or you have some storage systems with spinning hard drives that may not have the full performance for or capacity for your I would say home directories or for user directories, but you don't want to throw them away. You can think about using BeeGFS on top of this and running a central storage with aggregated performance and capacities, and creating a single namespace with some different hardware. So it can be a Dell server, some Supermicro servers, and maybe a Seagate storage. You can put this together, create your own namespace, and then you have something that you can use for at least a few years for getting this capacity and not throw away the hardware only because a cycle is over and maybe you need something else for this specific application. Most of our customers running these storages in very long time. So, and I would say a big part of our customers also using hardware that has already their first life closed and using hardware again on second life, at least for the capacity. Not so much for the high performance stuff, but if you think about high capacity solutions, spinning hard drives, and so that's what they usually do with their life. So I talked a lot about design and how systems can be configured, but how can I do this? How is BeeGFS controlled? Everything in BeeGFS is controlled over a command line. That's quite easy thing. I know a few customers sometimes looking and say, okay, I want to have a GUI. I need some kind of web interface to do something. But as BeeGFS is so easy to do, you need, I have counted it, you have 12 commands to install a BeeGFS system, so not more. So it's quite easy to use, and it's self-explaining. So we have a new tool with BeeGFS 8, and all commands starting with BeeGFS, and then we see here on the left side additional commands like benchmark, completion, copy, entry, health, index, storage, quotas, remote, that's an expansion on the back end with S3 storage, file system stats, targets, and so on. So, and then from there you can always get the next help and get your commands auto completed. So that's really easy to use. And if you start with BeeGFS 8, I think you need only a short time, and then you have the syntax and how it works in this, and then it's really easy to use. Another thing that is quite common to use on customers and that opens a complete new opportunity for customers and environments is BeeGFS on demand. BeeGFS on demand is the same software like we have it on our BeeGFS parallel file system installations. So BeeGFS on demand is what I call a different deployment option. That means you can install BeeGFS packages on all your compute nodes and utilizing the built-in NVMEs on your compute nodes and create a shared storage environment in a single namespace over all your compute nodes or only a part of your compute nodes. So BeeGFS on demand means on demand you have an example. You have 10 compute nodes and you want to run a job only on 5 of them. And you want to have an isolated storage for these 5 nodes because this job is creating a lot of small files, a lot of temporary access to the storage, but you need a shared storage because the nodes can share the data in between. And if you do this on a central storage, you easily come to a point where you need a very fast network, you need a very fast central storage, and you cannot utilize the internal NVMEs because they are not shared. You can write your temp files to your local disk, okay, that's fine, but you can't share them between the compute nodes. And here's where BeeGFS comes into play. You can install the BeeGFS software packages on these compute nodes. They are at this point inactive and running your jobs. And then you can use Beyond, and Beyond is able to spin up a temporary BeeGFS file system only on a number of these compute nodes and create for them a scratch file system that they can use for this specific job, for example. And this is something that is extremely easy to use. And you can put this into your job scheduler so that you say, for this job, I want to create a scratch file system that is running only between the compute nodes, has nothing to do with your central storage. It only creates a temporary file system between multiple compute nodes, utilizing their internal NVMEs as a storage target. And this is where the benefit comes. You don't need to invest in additional hardware for storage. You don't need to invest in additional network because these compute nodes most of the time are already connected to a very high performance, low latency network. And then you can spin up their temporary file system or only for this job or only for a specific number of jobs for this. You isolate the storage workload from your central storage. You can also isolate these applications. So if something goes wrong, it only goes wrong on this storage system, nothing else. You can isolate data for specific users. If you think about you have a cluster and you want to isolate a specific storage part, some kind of multi-tenancy, to say, I want to rent these 4 compute nodes and I want to have there a local file system, shared file system for all these nodes together, but I don't want to let this customer or this user running on my central storage. So you can create a isolated storage, isolated file system for this and give this only access to these nodes that are part of this job, for example. And what you can see here is if you have installed the BeeGFS packages with your package manager, that's the only thing you need to do. It's one line on the command line to say Beyond start, then say which nodes should be included here, which compute nodes should participate on this file system. That's in a node file. It's only an ASCII file with the host names. Then you say which directory they should use internally to store data. So this is their internal NVMe mount point that you want to use for this. And then you say where to mount. So -C means where should the Beyond file system mount it. So in most cases, mnt/beyond. And then that's it. That's all you need to do. So your job scheduler can fire this command. And then BeeGFS will start a script that is starting these metadata services, storage services, management services on these nodes that are listed in the node file, and then mount these automatically on these clients. It's a process less than 1 minute. you have fired up a temporary file system for this specific job, and you can utilize the storage that is included in the compute nodes. That's the most important thing. You don't need additional hardware for this. You don't need a storage system, because compute nodes these days are able to have multiple NVMEs already built in, and they have powerful CPUs to do this kind of work for the BeeGFS file system as well. And here the example, you see it's really easy also to implement with a job scheduler to do this for a specific job as a pre-preparation job. That's, as mentioned before, Beyond is the same software like we have on BeeGFS. It's only a different deployment model. It's exact the same RPM package, exact the same binaries, nothing special on this. If we talk about managing data, we mostly talking about how to get data into the storage, how we can manage capacities, usage of storage, how can we also train our users, or how can we do housekeeping processes on our storage to leverage the capacities and the resources that we have in the right way. So with BeeGFS 8, we have introduced a new API for data management. That means you can create storage pools between storage classes. So if you have some flash-based NVMe SSD-based storage targets, you can put them into a storage pool. You can have some HDD-based storage targets. You can put them in another tool. You can have an object storage that you may have already in-house that is running on MinIO or Ceph or whatever. Or you can also implement cloud storage that is using the S3 protocol, and put them together and create a BeeGFS file system that can utilize all these tiers together and then move data between these tiers without having any impact on the users. So that means usually you have a directory that is for fast storage, and you have a directory for, I would say, capacity storage. But if a user figured out, okay, everything that goes to this directory is fast, everything that goes to this directory is a little bit lower on performance, they will always use the latest and greatest and highest performance tier in your storage. And then you can try to educate users and say, if you don't need your data, please do some housekeeping, please move your data to something else. That's not what we see in the field. It's not what we see on universities. The administrators try to do this, but usually users are very, they want to have everything on the fastest stuff as always. And then we have the possibility to tier data between our file system. So for a user, the data is still in the same place, the data is still in the same directory, but in the background, we can say as an administrator, okay, this data is not touched for 6 months now. I don't want to have this data on the fastest storage tier, my very expensive NVMEs. I want to have this data on a HDD-based storage tier within the same namespace. So I moved this data from the NVMEs to an HDD-based storage. For the user, nothing changed. They have their data still in the same directory, still in the same place. They don't know where the data actually lives. They can ask for, but on the first view, they only see their directory and the data is there. And may after a while, after 1 or 2 years, you can say, okay, I want to move these data away from my BeeGFS file system. I want to put them in an object store because I have to preserve the data for at least 10 years. Nobody is working with this data, but I need to hold this data for the whole time. It doesn't make sense to have these data on a high performance file system. It could be better to move these data to an object storage that has a ransomware protection, that has some versioning activated, and so on and so on. And this is something you can also do with BeeGFS and say, I want to expand my file system on the back end with a remote storage target, what we're calling. And this is an S3 bucket where you can move the data from your file system into this object storage and then have only a stub file or an empty entry in your metadata so that the user see the data, but the data is no longer physically on your BeeGFS. It's already on the object storage. And then they can retrieve the data from there in case someone is asking for this. So this gives you the possibility to manage the data in their life cycle, depend on their actual need and how important they are. I mean, it could be that you say, I have project data 2 years ago, and now I have a similar project. I want to read the data again that I have processed during this time. Then you can stage back the data from the object storage in the fast tier and say, okay, now we're running a job that is actually asking for this special data. What is the biggest value here? The biggest value is you don't need to spend petabytes on NVMe storage because you don't have no other option. You have to be always online. So you can say, I have 100 terabyte or 200 terabyte on NVMe storage. I have maybe 500 terabyte on HDD storage. And then I have my object storage that is maybe a multi-petabyte environment where I can store my data, or where I also can share my data with someone else. If you think about how can I get my data into my HPC cluster, and how can I get my data from the HPC cluster to customers, to my development team, or whatever. You can also use an S3 bucket for this. This can be cloud-based, this can be on-premise based, where the dev team can put all the data in. And then if the HPC cluster has some time for you, they can read the data from there, import them to the BeeGFS file system, operating the data, getting the results back to the object storage, and your dev team has the results from their HPC run. That's some of the management functionality that we have now with BeeGFS 8. And this depends a little bit on the workload, how you share your HPC cluster with your customers, with your users. And this is one of the features that we have with the BeeGFS data management. We call this remote storage target because this can be in the cloud, this can be on-premise, can be somewhere a customer or user side. This is mostly or most of the things S3 based. And we're also supporting here S3 Glacier API. If you think about storing data for a very long time in AWS, for example, they have the S3 Glacier option where you can put this on tape. And this is something we're supporting in AWS Glacier, but also on-premise. There are a few archive vendors, they offering a solution where they do S3 object to tape. And this is something we're also supporting here. We have a few partnerships where we have this solution in place. Another data management API, or another feature of this API, is our watch. Watch is some kind of event listener from the file system. So this is something where the file system can tell you everything that happens inside the file system. For example, user A created a new file in this directory. It could be that you are interested in getting this information. For example, if your compute job is finished and this will write a result file, or your checkpointing is writing checkpoints and they are finished. Maybe this is an interesting information for you to get informed. Okay, the checkpoint is now written. I can copy the checkpoint to something else, or I can copy the results and can offload the data from here. Or a specific user has read access to specific files. I want to do some kind of auditing here and will get informed every time someone is reading data from this directory. Especially if you work with sensitive data, it could be a requirement that someone says, we need to be informed not only about who is reading files, but also who is deleting files, who is writing new files. All this can be communicated via the watch daemon or the API. So if you have interests in events that happen inside the file system, you can subscribe to this BeeGFS watch system, and then this will inform you only about these events that you are interested. Not in everything, it would overwhelm everybody, but you can create a filter and say, I want to be informed about everything that belongs to this specific rules. Another feature that comes with the data management API is our parallel copy tool. And this is a very useful thing that is not so much promoted, but a lot of administrators, a lot of people in the industry know that it can become a very, very large challenge if you have to import, export data from a POSIX file system to another one. If you do this with rsync, you have a single thread. If you do this with different additional tools, you need to install MPI or something like this to distribute this over multiple clients. So it's a little bit of a challenge. With BeeGFS copy, we have a built-in tool that comes with the file system and comes with the client. And the challenge here is you can put a single copy command between two POSIX file systems. This will be a single thread usually. With parallel copy, you can say, please do this in 3, 4, 5, 10, whatever threads at the same time. So you no longer depend on latencies and bandwidth on the Ethernet. So you can say, I want to utilize the full bandwidth that I can get. So no matter how much latency we have for this. You can also utilize multiple physical nodes that are connected to both file systems or both storage systems, and then utilizing multiple streams on multiple nodes at the same time. Imagine you have 4 servers connecting to an Isilon NFS server, and there on the other side, they have also connection to a BeeGFS file system. And then you can stage in, stage out data from BeeGFS to the Isilon or vice versa, and say, on one side, I have an NFS mount, on the other side, I have BeeGFS. And then I use 4 servers at the same time to move data from the Isilon into BeeGFS, do my operation, and then moving them back to an NFS storage. That's something that parallel copy can do. It's built in with BeeGFS. You don't need additional software to install. The only thing you need is to install the BeeGFS client software and the BeeGFS copy RPM package on these servers, and everything is done. It has its own distribution model. It has its own communication between the single nodes. It's built in and no additional software. That's what we say. There is BeeGFS is ease of use. It's not only easy to install, it's also easy to use in an environment like an HPC world. And here a few tools that also can be combined. It's the copy tool that I talked before. It's a parallel thing that you move stage in, stage out data from different file systems, not only between BeeGFS, also if you have an NFS, Lustre, Spectrum Scale, something local, you can use it. And not even a single copy command of a single file that's very large to a different server can utilize this, because we're doing not a single thread. We can start multiple threads on a single node to a single copy process, and then it will cut this file into chunks and do this in parallel. So even if you copy a large file from A to B, this will already as a benefit from using the copy tool instead the standard copy command or rsync command that you have with a Linux operating system. Index is our metadata file system index that has all the information that the metadata have also on an index. This is external. That's mostly for data management features and search functionality. If you want to see files from a specific person, from a specific group, for a specific project, then you can use this index. The index is an external database that don't affect the local metadata performance during operation, because this is, I would say, a mirror of the metadata on an external database that is built for specific search functionalities. Storage pools, I already mentioned this, that we can have different storage classes within the same namespace, within the same file system, and you can say which data should go into which pool. You can do this on a file base, you can do this on a directory base, depends on your workflows and depend on what you try to achieve. And remote is the sync and offload data to an on-premise or cloud-based S3 bucket to offload data and free up space on your very expensive high-performance storage solution. Okay, back here to the functionality. If we're talking about storage, remote storage targets, that's something that is the extension on the back end, S3 extension on the back end, to get more performance and more capacity and sharing your data with other institutes, for example. This is what remote storage targets can do for you. BeeGFS copy is the parallel stage in, stage out tool, copy tool that we have to get data managed between different storage classes and storage systems. As I mentioned before, a lot of our customers have different storage solutions in place. So they need to stage data between different storage solutions. And this is the answer. This is the tool that we provide here. And we have seen significantly more performance than on a single copy. So we're talking here about the 10 to 16 times. Sometimes if you do a large environment, you can have up to 100 times the performance for a copy job compared to a single copy on command line. And BeeGFS Index, the external metadata database for searching and incremental scans for this. It has the BeeGFS specific metadata in this database and also the file system metadata. BeeGFS specific metadata is something that is where is the data stored exactly, on which storage target is the data, and so on. What is the chunk size, what's the inode, and all these things. So these are also stored in this index so that you can also use this, for example, to evacuate a specific storage. If you say, I want this server is outdated, I want to migrate the data from this old storage to a new one, but I want to do this online. I don't have the time to do this in a downtime. I want to copy the data within the file system without notification for the users. They will find their files always in the same position. You can use this and say, move all the data from this old storage target to a new one, and then delete the data on the old one and change the metadata so that the user will always find the data in the same directory on the same place where they put it originally. Okay. In BeeGFS, we have a community and we have an enterprise edition. And in total, this is exactly the same software, with the difference that the community edition has the file system only, and the Hive Enterprise Edition has all the additional features. And for the community edition, you don't need a license. You can install this, you can, for test purposes, you can download the software from our repository, and then you have the file system functionality available. The community edition is limited to 1 petabyte in total capacity. You can use ACLs, access control lists, you can install the monitoring tool, and you will get support over the community and mailing list. So usually community is on its own. So if you want to try out BeeGFS, if you want to play around a little bit, if you want to see if your hardware that you have maybe in place can run with BeeGFS and what performance you get, then this community edition is a nice thing that you can use and see, get familiar with the command line, trying out what's going on, how much effort is it. This is what you can use here. And with the BeeGFS Hive Enterprise, this is a license that comes with a support contract. So it's a subscription for a specific runtime. And with the Hive Enterprise, you will get all the features in once. So there is no additional licensing for specific features. It's really all in one. If you have this Hive Enterprise, you will have all the features available. You will get unlimited capacity because BeeGFS is not licensed for capacity. That means we don't count in terabytes or what you have to pay for. We have unlimited license. What we're counting is the number of storage and metadata servers, but this is, I will explain a little bit later here. You will have unlimited capacity. You will have the access control list, same like we have it on the community edition, so that you can work with expanded attributes and access control lists to get your files permission organized. The monitoring tool is available like on the community edition. You can also ask the community mailing list for help if you have some questions regarding configurations or something, but you also have the support option. So you have a professional support. That means we can offer support solutions up to 24/7, 4 hours response time. For this, our standard support goal is next business day. That means if you have a valid enterprise license, you have unlimited number of questions or support cases that you can open with us. You can send us an email, and then we will have a look into this, going remotely on your system if you like, and then we can fix it together. That's a big benefit of the BeeGFS Hive Enterprise solution. You have all the high availability features that I talked before with the metadata, with the body mirroring, with the high availability shared storage configurations. all these features coming with the Hive Enterprise edition. You have the possibility also for quota and quota enforcement. So if you have group or user quotas, you can enforce them and say, okay, this group can have access for this storage pool. So quotas are based on storage pools in BeeGFS. That means you can give different quotas for the usage of NVMe versus HDD storage, for example. If you want to set a rule and say, my users can use 1 terabyte on NVMe, but 20 terabyte on HDDs or something else, then these are different quotas. They are organized by storage pools. Storage pools, I mentioned before, different storage qualities or classes can be combined, and then we have a single namespace with different storage pools, and you can migrate data between these storage pools. Remote storage targets, backend expansion, getting more capacity over an object storage in the backend. The parallel copy tool I mentioned already. The watch is the event listener that informs you about things happen in the file system that you may be interested in. And the index is the external metadata index so that you can use this for search without having an impact on the file system performance. Important thing, if you have a lot of search functionalities in your software and you need a lot of search on your storage, you will always see that these finds or something like this will create a lot of load on your metadata environment. And sometimes if you think about your Mac or Linux or Windows laptop, if you search in a larger storage, it will completely block the system from working, because usually these find or these search functionality have a high priority. So, and this will have impact on your own, on the rest of your system. If you think about this in a small scale, that's already something that's not happy about this. If you think this in a large scale, this can take a lot of load, and maybe your compute jobs that should have the highest priority will be impacted here. That's why the index is something where we put the metadata outside of the normal file system operation, and then you can search there and have no impact on your daily business, on your compute jobs that are running. Here's a short summary of what these features are doing. We will present or we will share these slides after the presentation with you, so I don't want to go over this. You can read if you like to have an explanation what these features are doing at the moment. Okay. How BeeGFS is licensed is very important. I mentioned already we have this community edition that you can download and play around a little bit, but as long as a partner is doing the installation, or if you do this in a production environment, you need an enterprise license. Specific, if you want to use one of these enterprise features, you need an enterprise license for this. And we licensing only the number of servers where a metadata or a storage service is running. We don't count clients, we don't count capacity, we don't count the management servers. We're only counting the metadata and storage services, servers where such a service is running. If you do this in a converged setup, that means if you put metadata storage together in one single physical server, then you need only one license for this. Yeah? That's what we mentioned here in converged. That means this is one server where metadata and storage services running at the same time. You need only one server. Management is not licensed, monitoring is not licensed. It's a feature that is available though. If you go to our website and you want to download the software, you see this traffic light on the download page. And here is explained in short words what is allowed and what is not allowed with the community versus the enterprise edition. And I think it's a good example and a good starting point if you think about using BeeGFS in an enterprise or community edition to see what's allowed and what's not allowed. I mean, it's something like you usually have on the end user license agreement in a written text form. Here is a little bit condensed and maybe a little bit easier to read. If you use community edition, it's for internal use only. If you start running BeeGFS and offer this as a service for other users in a shared environment, for example, then it's not allowed to use the community edition. Then you need an enterprise license for this. There's also an enterprise trial version available where you can download and trial install a temporary license key for 60 days. So if you want to do intensive tests, you get a test license for 2 months, and then you have all the features completely free. Also, the number of servers are completely free for this enterprise license, enterprise trial version. Now, redistribution, for sure, if you want to redistribute this, you need a contract with ThinkParQ. But what you can do, you can change BeeGFS on your own installation. BeeGFS is source available. That means you will find the source code of BeeGFS on our GitHub repository. And if you want to change BeeGFS in a way that fits your workloads, that fits your specific application needs, this is allowed. So it is sometimes we have a few customers doing this. They have built their own stuff around BeeGFS or with BeeGFS, or have manipulated BeeGFS functions because they have specific application, most of them homegrown, that want to take advantage of these changes. You can do this. This is allowed, but it's only for your own usage. You can't distribute this to other customers that may have the same challenge. If this is the case, reach out to us and we can talk about if this could be a contribution to the BeeGFS software, if we put this in our own code, or how we can handle this in this. Okay. And from here, I would say I hand over to Dominic again for our go-to-market approach. You're on mute, Dominic.
I'm conscious of the time, and I know we've got a couple of questions that I'd like to go into, so I'll go through this fairly quickly. Go-to-market approach. Yeah, for the most part, in most countries, we work through value-added resellers. That's what we're doing in the case of Slovakia. We also have some disties that we use for some of the big hardware OEMs. Next slide. Yeah, so in terms of responsibility, what normally happens is we train up the partners to first of all sell the product, and secondly provide level 1 and level 2 support. And if there are cases that require level 3 support, then that comes directly to us, and that's how it would work in the case of Slovakia. The basic support setup is next business day. 9 to 5, but there is an option, if you have, if you need as an end customer, or if you have end customers who need 24/7, then we can offer that as well. Yeah, that's some of the partners that we work with on a technical basis. So we have got things like reference architectures with Dell, that sort of thing, and you can see some of the big installations that we have there. So it's all, I won't go into any of them in great detail. Distributor for Slovakia. So we've teamed up with Agora Plus, who we've been working with in the Czech Republic for a number of years. They're based in Prague and Brno, so not very far from Bratislava, and they have experience looking after the Slovak market, even if they talk a little bit funny.
Okay.
Oh yeah, we've got the end user stories as well. So do we do the questions or the end user stories, Ingo? What do you think?
I'm not aware. What questions do we have? Maybe we can do questions
they're
first.
in the chat. So Milos has asked, BeeGFS is great for large files, but in AI, you often deal with millions of tiny ones, checkpoints, data shards. How do you set up metadata servers so that this doesn't become a bottleneck? NVMe versus SSD, directory striping, what actually moves the needle?
Okay, good. That's what I mentioned at the beginning with the scaling of the metadata services over multiple nodes. If we have these very heavy AI workloads where we create billions of files, in BeeGFS, we have a distribution model where each subdirectory will be handled by a dedicated metadata service. We can start multiple of these services in user space. They have their own target where they store the metadata for this specific directory. And if we have multiple of them, we will take an algorithm to distribute the directories over multiple metadata services. This gives you the possibility that if you have a heavy load and have billions of files, if they are not all together in a single directory, they will be served by multiple meta services. And this gives you more performance overall in a large cluster than if going only with a single metadata service or having a fixed structure on how metadata is organized, including the subdirectories. So if you have a directory has already 5,000, 10,000, 20,000 files in it, and someone creates a subdirectory, from there, the next metadata service will take care of all the files that go into this subdirectory. And with this, you can distribute the data over multiple physical servers, but at least over multiple services running on the same server and utilizing more CPU cores to do the metadata work as well. So that's the way how we distribute metadata, starting multiple services and then distributing the single subdirectories on different metadatas. With this striping, you're actually right. This can become a challenge and a bottleneck if it comes to very large number of files and a very, I would say, large number also of storage targets. You can configure this striping on each single file, on each single directory differently. That means if you have a lot of small files and you may have NVMe storage below that is optimized for small files, also from the file system that we're using below, then you can say everything that goes to this directory or everything that goes to this target has a different chunk size and a different access pattern. So you can say, I want to have this data distributed over 4 storage targets. Other data will be distributed only to a single storage target. So what it means is we're cutting the file into these chunks, and then we send these chunks to the storage targets. And you can configure how many storage targets you want to be involved in this single file writing. Standard is 512 kilobyte chunk size and 4 storage targets. This is what our standard is. But it doesn't mean that this fits all the AI and ML workflows that we see out there. Most of our customers doing here a tuning, and if they know what is the exact block size of the application, how they are writing, what is the expected file size of this, we can also say we want to optimize the underlying storage for smaller handlings, and then we can also say we want to have a file chunk only 64K, and then we can write in chunks 64K or larger or whatever size you match with your application. And also the number of targets can be changed. For very large files, more targets sometimes have a benefit, getting better performance. For very small files, a smaller number of targets is beneficial. So, and as you can do this on a directory and even on a file level, you can optimize your system in a way that you can say the system can handle small files, also large files, and depend on the application, the directory you use for this specific application, you can set some presets and say, okay, everything that goes to this directory will be handled in an optimized way for this application. If another application is working differently because they're having larger chunks and maybe a larger block size from the application, you can also do a configuration there and say this directory is optimized for this specific application. And if you want to do this, you can also use your job scheduler to create a directory exact for this job with the optimized setting for this. So this is very granular, and you can really do a tuning for, if you like, for each specific application. Most of our customers doing this, if they have a very demanding application, they're doing these tunings exact for this application for their BeeGFS file system. Hopefully this answers the question.
I hope Milos is happy now. We've also got a question from Uri. Main difference to classic, I think he's talking about high availability. Main difference to classic RAID systems seems to be a massive distributed environment, various services and cloudy features. Would that be correct?
That's correct. If you have a RAID
Yeah.
system, classical RAID system, you have an 8+2 RAID 6, for example, you're utilizing 8 disks out of 10, and then you get a certain performance out of these RAID set. This could be 1 gigabyte a second, for example. But if you want to have more performance, you can do a larger RAID, for example, but then you're struggling with write penalties, for example, if you write smaller files, then and in BeeGFS, you can collect all these RAID sets, put them together in one single namespace, and create a larger file system and also more performance, because with more RAID sets, you also add more performance on it. So that's more or less linear. If a single RAID gives you 1 gigabyte a second on HDDs, as an example only, then you will see if you put 2, 3, 4, 5 RAID sets together in a namespace, then you will get 5 gigabyte a second. So that's the way how you scale the system up over the point of a single RAID system. And even if you do a RAID protection on a per server base, think about having a server with 8 NVMEs. You put a RAID protection on these NVMEs with Xenor or another solution, for example, then you get from this server 50, 60 gigabyte a second. If you put multiple of these servers together, then you will see 100, 150, 200 gigabyte a second in total. That's the way we doing something similar like RAID. That's right, but we do this on the next level. We can collect multiple RAID systems and put them together in a single file system.
Okay, and Yuri also asked about security.
About security, there is a few things that coming on over the last, I would say, releases that we had. In the past, security was not a big thing in HPC environments, to be honest. The most customers only asking for performance, not for security. But in the meantime, we have a few things that we have put together. First of all is that we need a shared secret. So we have a con-out file that prevents different clients from accessing the system without having this key. We also have an encrypted communication between the metadata and this management and users. If you do these CLI commands, you need a TLS certificate to communicate between these processes so that nobody else from outside can say, okay, I'm root on this local machine. I will do some reconfiguration stuff here. That's no longer possible. There is a TLS certificate needed for this specific node and for communication with this. So there are a few things that coming also in the future multi-tenancy. Right now, we don't have this in a full state, I would say. We have some partial points, but not a full state here. But yes, security becomes more important in shared environments. And right now, we have the TLS certificate for the communication between the services itself. And we have the con-out file to have a shared secret so that not everybody can mount the file system and have access to it.
Great. Thank you, Ingo. So, it's almost top of the hour, so we're probably not going to have time to go into the end user stories, but a lot of these are up on our website. So, please feel free to check them out. There are also a couple of new customer stories that we're working on at the moment. Those should be going up in the next couple of months, so feel free to check back. Beyond that, just to call out, if you want to test BeeGFS, if you want to use BeeGFS, you've got the community version, which you can get from our repository on our website. You've got the 60-day test version of the full enterprise version with the enterprise features that Ingo outlined. And then, if you actually want to invest in a full BeeGFS license, either reach out to me directly, or you can also contact Agora Plus in Brno, and we'll put together an offer for you. And obviously, if it's a complicated installation, then we'll get Ingo and our pre-sales team involved to make sure that it's configured in the way that you need.
If I can jump in here and only in a few seconds, a few customer stories. We have here TACC, Texas Advanced Computing Center. They built a solution where they have 560 compute nodes put together. All of them have 2 AMD 64 core CPUs in, 16 GPU nodes, And they built a Dell-based storage solution on 8 petabyte on spinning disk to operate their Lone Star 6 HPC cluster there. The benefit here is that this is a full HA environment, and this is a very large installation. It's already 2 or 3 years old, so 6 petabytes these days becoming more common. But on the other side, we have also a smaller user here in Europe. It's the University of Pisa. They had a very small setup with 2 servers from Supermicro, putting some NVMEs into these servers. So they have on each server 12 NVMEs. They have 2 NVIDIA DGX A100 boxes there. And with the 2 servers from Supermicro and the 12 NVMEs, they get easily 60 gigabyte a second for read and write. And this is a storage system that is in a rack for use in a rack and give you something around 50. The newer platform from Supermicro can deliver up to 100 gigabyte a second from a 2U system. So what you can see here is you can create very small setups with a super high performance, but you can also work on very, very large multi-petabyte environments, depend on the use case. As Dominic mentioned, on our website, there are more details about it, how this works and how this was set up. And if you're interested, I can also send you a few of them via email. So if you have some questions, reach out to us and we try to answer these.
Yuri's got a question about access control lists, but I'll try to answer that one by email.
Yeah, there are access control lists on the file system itself. That's correct. And this is a feature that is available for both versions.
Okay, so I think with that, we're finished. So just once again, thank you to everyone for attending. Thanks for your interest. Thanks for your patience. Thanks to Lucia and Bojidara for the information. And
from our side also, thank you, Dominic and Ingo, for guiding us through the architecture and practical steps of BeeGFS. And we also appreciate all participants for joining and for your questions. Just to remind you, the recording will be available on our YouTube channel in the coming days. We will also share the presentation slides with you, and I will include a short post-webinar survey, and your feedback is very valuable to us. So please take 2 minutes, fill it out. It helps us improve future sessions. And on behalf of the National Competence Center for High Performance Computing in Slovakia, we thank you for being with us today.